Hello everyone. Ever since I started using Langchain, I'm trying to automate whatever I can for my day-to-day tasks. I automated shell command generation for my daily usage, and in this video, I'm trying to automate SQL query generation as well as execution. Well, my primary use case is for ad hoc reporting asks as well as doing my on-calls. I don't want to spend a lot of time figuring out queries, and I just want to use this tool to quickly generate a query for me. With this tool, anyone can actually talk to the database without knowing anything about SQL queries. So this tool supports relational databases only. We can run queries on MySQL, on Postgres, on AWS RDS, or any relational databases basically. So why not just use GPT-4 directly? The problem with GPT is it needs to know my system context. So for it to actually form a coherent query, it needs to know my schema, some sample rows and whatnot of my database. While I used to copy the details manually every time I wanted a query, this process can become a bit tedious, and with Langchain, the Python framework I'm using, I'm trying to automate this part also. So we just have two components. One is Langchain and the second is the OpenAI GPT-4, which is the LLM powering our Langchain. So we'll have an agent running which reads the user's query, then reads the schema of the tables and fetches sample rows from the relevant tables only, and then sends all this information to the LLM and asks the LLM to generate the query. All of this happens automatically. The user just needs to enter the query. Once the LLM returns the query, our agent actually executes it on the database provided. We will, of course, add some guardrails to prevent any write operations as well as to prevent any select tasks on a big database. So the database we're using is called Chinook Database. It's an open source database and it contains information related to a music store. It contains tables for artists, invoices, customers, albums, tracks, and something on those lines. So you can download it from GitHub. Just Google Chinook Database. I'll add a link in my description and then you can play around with it. So the first thing we'll do is we'll install our dependencies, Langchain and OpenAI. I'm using a virtual environment. It's not compulsory, but it's a good practice. Next, we'll create a new file, sql.py. We'll create a getLLM method. Inside it, we'll set the OpenAI API key as our environment variable. And then we'll create an instance of OpenAI specifying the model is GPT-4 and the temperature is 0. The reason for temperature being 0 is because we want our models to be deterministic and accurate. So lower the temperature, more the accuracy and more the deterministic responses. We'll do the relevant imports. We'll call this method and get the instance. We will move our downloaded database to this folder. Let me go ahead and rename this to chinook.sqlite. So now we'll connect to the database. So the way to do this is by using something called SQL database. This is a class from Langchain, which is simply a wrapper over a very popular library called SQL Alchemy, and we'll specify the DB URI. Let me do the imports. So in case of SQLite, since it's in a local directory itself, the URI will look something like this. Now we don't need to use SQLite, we can use any database. The SQL Alchemy supports almost all the databases. For example, in order to connect to an AWS RDS, we use something like this. We specify our database type and the driver which we want to use. In this case is MySQL, the username, the password, and the endpoint along with the port and a database name. We can do this with Postgres also. Let's say we want to connect to a Postgres. So what we'll do is simply we'll mention the database and engine and the connector we'll be using along with the username, password, and so on. So now we'll create the toolkit and the agent. So the toolkit is basically a collection of the tools which an agent can use. So this is something which comes pre-built with Langchain for using with SQL agents. So if I go inside this, we can see there are 4 tools which are present in this toolkit. One is query SQL database tool, and I can see the description is effectively that the input to this tool is a caret SQL query, and this will execute the actual query. So this is a tool which will talk to a database and execute it. The second is info SQL database tool. This just takes a comma separated list of tables and gives a sample rows and the schema for those tables. Then we have list SQL database tool. So this just gives the list of tables in the database. And we have something called query checker tool. Query checker is used for just double checking whether a query is correct or not before executing it. Next, we'll create the agent using the method called create SQL agent. So this is just a handy method provided by Langchain for us to create an agent for interacting with SQL databases. We are passing the toolkit and the LLM. Let me fold this method so that I can replace this with the actual API keys before the execution. So now let me just wrap this up in an infinite loop, and the user can keep on asking the questions and agent will be able to answer it without the program being terminated. Now let me go ahead and execute this. I want to know the number of albums by Led Zeppelin. So this is my query. So this is my output, 14 albums, which is correct. I checked in the database. So let's go over the flow once. The first thing which happens is the LLM tells our agent to use the list tables tool, and our agent executes it on a database and it gets the list of the tables. So the agent then passes this observation, basically the result of the execution, to the LLM, and LLM then, depending on the question, it takes a call that the relevant tables are album and artist, and then it asks our agent to use the tool schema SQL DB to get a sample schema as well as some sample rows. So agent executes this tool and then passes this particular result to the LLM. We can see the schema along with some sample rows. Now that the LLM knows the schema of the album and artist table, it can write a query, and it uses something called query checker SQL DB. And this is the query. Now our agent first uses this query checker and just validates whether the query is correct or not. And if the query is correct, it tells the LLM that the query is correct and it can execute it. So the LLM tells the agent that, okay, use query SQL DB to actually execute it. Our LLM then executes this query and gets the answer 14. So we can see the query is select count star from album, and it does a join on the album and artist table and where the artist name is Led Zeppelin. So this query is correct and the answer is also correct. So this is how the entire flow works. Now if I want to know the total sales per country and get the country whose customers spend the most. So this is a result. This is the query. It's selecting the country and the sum of the invoice, doing an inner join on the customer ID and the customer ID in the invoice table and grouping by the country. And the result seems about right. So we can see it's able to also do relatively complex operations involving joins. I'll ask it to create a new artist, AI artist. So we can see the result over here. So it tells us that it cannot create a new artist because it's not allowed to make any DML statements, basically any modifications, but it does tell us the query which we must run in order to execute it. So insert into artist name values, and we're passing the AI artist as the value. So the reason why it's not actually executing the DML statement is because in the prompt we have mentioned to not make any DML statements, inserts, updates, delete. So this adds a good guardrail which can prevent us from making any changes to the database, any write operations to the database. We can do a lot of things by modifying this prompt. For example, we can pass a conservative number as top key result so that our select statements do not overload our database. Or if we are confident enough, we can just remove this parameter altogether. So one thing how I personally use this is I connect this to my pre-prod or my beta database, and then I ask the agent to execute and run the query. If I'm happy with the query, I just copy it and then run it in my prod database. The advantage here is, one, we don't want any risks with the prod database. And second, we don't want to send any PII. Mostly if you have some custom database, you would probably have some personal data of the customer, and we don't want to pass that information to GPT.